Welcome back to Computer Science 4303. We can see here today we are at lecture number 3, where we're going to talk all about assignment number 1. So what I've done for you today is I'm going to go through the entire setup process of how you'll do the assignments in the course, and using Visual Studio for those assignments. Now, for people who are not using Windows, you're not going to be using Visual Studio, but pretty much everything else should be the same. All the code that we write is going to be cross-platform, so you won't have to worry about any weird stuff happening in other operating systems. But I do want to go over the setup and installation instructions for the first assignment, and then that's going to be the same for all the assignments. And the added benefit for the people who are planning on doing the StarCraft project is that this will help you set up for that project as well. So here you can see on the course spreadsheet that I have this C++ setup instructions text file here for you to go. So if anyone out there in the chat has already set this up, please let me know. I'd be curious if anyone had any issues with it. So here we have a text file, and let me zoom in on this text file a little bit. So at the top of the text file, there's a few important links. So the Sfml page. So Sfml is the simple and fast multimedia library that we'll be using for the course, and that just essentially lets us do a really fast user interface for the course. If you're not familiar with Sfml, there are some tutorials here on the website. You don't necessarily need to be too familiar with Sfml itself, because most of the drawing and stuff that Sfml does, I've already done for you. So it's okay if you're not an expert in Sfml. We're basically just going to be doing raw C++ around that library anyway. The Sfml website has some Mac instructions for getting up and running, but I recommend trying what I have here first. So what I'm going to do is I'm first going to scroll down to the Windows instructions, because they're the most complicated. I've been told that the Mac instructions and the Linux instructions just work, and I'm running on Windows right now. I had a Linux virtual machine set up, but it stopped working right before the lecture. But basically, all you have to do is type this command, and you're done. Okay, Linux is great for development, obviously. Windows is going to be a bit more of a pain, but we'll get through it today. I do not have a Mac. I've been told that this installs and works properly. So you can use whatever text editor you want, and then you'll be compiling things using G++, using this this command from the assignment root directory. So Linux and Mac are a bit more straightforward, but let's go through with Windows, because most of the people in the class will be using Windows. Okay, so I haven't tested this on this virtual machine yet, so I like kind of doing this live, because it's going to show me what potential issues you could run into, and then we can solve them as we go. And the first potential issue, which I saw only about 15 minutes ago, is that there's a new version of Visual Studio out, and I forgot about that. So the first thing you have to do is download and install Microsoft Visual Studio 2019. So just keep in mind that Microsoft, in their infinite wisdom, has two products. One of them is called Visual Studio. That's the one we're going to be using in this course. Visual Studio is an IDE. It does C++, it does C#, it does like app development, it does a bunch of crazy stuff. That IDE has built-in compiler for C++. So Visual Studio is the thing that we're using. The other project that they have is called Visual Studio Code. That is not what we're using for this course. So if you've installed that blue program, Visual Studio Code, it's an amazing IDE, but it does not have a built-in compiler for C++. So we are using Microsoft Visual Studio 2019. So I understand that that's a little bit confusing, but it's Visual Studio, not Visual Studio Code. That's a separate program that's unfortunately named. All right, so unfortunately, Visual Studio 2022 has just been released, and all of the assignments are done in Visual Studio 2019. Now, I'm going to, after this lecture, try and maybe update the assignments to Visual Studio 2022. However, I want you to download and install Visual Studio 2019. So I've included a link here. You can still download and install older versions of Visual Studio. So if we go over here and we paste this in, then you can scroll down and get Visual Studio 2019. The only annoying thing about getting this is that in order to use Visual Studio, you have to have a Microsoft account. So I'm sure if you're using Windows, you probably have a Microsoft account anyway, but you can download Visual Studio 2019. Now, that's the only step that I've already done. So I did that behind the scenes because depending on your internet connection and computer speed, that can take upwards of maybe an hour, right, is actually installing Visual Studio 2019. Just make sure when you install VS 2019, like the free community edition is fine. Just make sure that you install the C++ development tools. Okay, so there'll be a checkbox there that says C++ development tools. That's all you need. You don't need the game development tools or the Xbox or the Android or anything like that, just the C++ development tools. Okay, so I just wanted to point out that yes, there is a new version of Visual Studio out. And for next year's courses, everything will be updated for Visual Studio 2022. But this literally came out, like, I think within the last month or two, and I didn't have time to update the entire course to do that. Also, Visual Studio 2022, it's very focused on the 64-bit applications, and we are going to be using the 32-bit applications for this course. Not that there's a real good reason for that, other than the StarCraft stuff all has to be done in 32-bit because the StarCraft program that was written in 1998 is still 32-bit. So in order to write programs that interact with that properly, your programs have to be 32-bit as well. So we're going to stick with the 32-bit version of stuff for the Windows users in this course. For the Mac and Linux users, it doesn't matter. You could use the 64-bit version. All the code will be exactly the same, and none of that should really matter. So apparently there is a Visual Studio for Mac, but if you are using a Mac, you're on your own if you try and do that, okay? Because the Mac instructions that I have do not use Visual Studio for Mac, and I'm not sure if my project files work with it. So you can try it, but that is not the official way to do this course on a Mac, okay? Just keep in mind that I literally do not have a Mac. I've done my best to keep all of this stuff operating system independent. So please just try it if you want, but I can't help you if it doesn't work for you. Okay, so that's the first step, is downloading, installing Visual Studio 2019, and it's probably going to be the longest step because it's a large program. Next is to download the 32-bit version of Sfml. So if you go to the website for Sfml, which is up at the top, you're going to get to this website, and then you're going to click on Download. And then you're going to click Sfml 2.5.1. So that's the latest stable version. It's been out for a while now. We're going to click on that. And then over here, we're going to download this version of the library. Okay, so it's the 32-bit version. So we'll be writing a 32-bit program. As I said, the code doesn't change. It's just sort of operating system stuff that I'm not going to get into. This says Visual Studio C++ 15 2017. That means that this version of the library was written for 2017, or sorry, Visual Studio 2017, but it's completely compatible with 2019. So that's the one that we're going to download. So let's click download there. So I'm going to save this. And now what I'm going to do is I'm going to go to my desktop where I have a COMP4303 folder, and I'm just going to save that file there. All right. Now, I understand you're all senior level computer science students. You don't need to be handheld like this, but every step of the way that I do this in a video is one fewer email that I have to answer when something inevitably goes wrong for somebody. So I like doing it complete. All right. So we've downloaded that. Now, extract Sfml to a folder on your computer with no spaces. So I highly recommend creating a folder called C Libraries and extracting there. So for example, this will result in C Libraries Sfml 2.5.1 as the Sfml directory. So let's move these instructions over to the side real quick. So over here in Windows Explorer, I've just got my C drive open. So I really like to have one folder that contain all of my libraries. So I'm going to do that here. So all my development is sort of in the same place. Now what I'm going to do is I'm going to minimize this, and I'm going to come over here to where I downloaded the Sfml zip file. I will move it over here, and then I will right-click, extract here, and that should be exactly what I need. So now I have C libraries sfml-2.5.1, and in here I have bin, doc, include, lib, all these files. That is where the sfml directory resides now, okay? So if you've never used C++ before, and if you've never used external libraries with C++, essentially what's going to happen is your library, at least on Windows, is going to have like bin, that'll be where all the DLLs are. Include is going to be, that's where the header files are, and lib is going to be where all the precompiled lib files are that you're going to link against in your program. So that's where this library is. If you're using a Mac or if you're using Linux, whenever you do sudo apt-get install sfml-dev or whatever it is, that's all done for you behind the scenes. In Windows, it's a bit more of annoying to set it up. All right, so now we've extracted that. Let's go back to our instructions. Create a Windows environment variable that's going to be used by Visual Studio to point to the sfml include directory. So in this step, it seems like this is a bit of overkill, but it really does help with the smooth running of the course, okay? So essentially what you have to do now is whenever you are going to have your IDE, which we're using Visual Studio, it needs to know where these libraries are, okay? So in Windows, there's something called environment variables. So if I look at this instructions here, so it's going to say, click the start menu, type env, and then click edit environment variables. So if I click the start menu, I just type env, edit the environment variables. All right. So now this window comes up. It says click new. So I have to click environment variables first. And then you can either edit environment variables for just your user or for the entire system. It doesn't really matter. So let's just do it for this user. So we're going to click new, okay? And that's going to pop up a window. And the name of this is going to be sfml_dir. And then the variable value up here, well, if I go over back here and then I just right click, copy address as text, and paste it in there. So you don't necessarily have to have your SFML installed into this exact directory, but wherever you do have it installed, please put an environment variable and link it to your install directory, okay? Now, in the instructions, it said, please have a directory with no spaces. So apparently there's a weird interplay in Windows between environment variables and Visual Studio, and if there's a space in this folder name, it may not work correctly, okay? So just try not to have any spaces there when you create this variable. Okay, so that environment variable is created, and just realize that if you had Visual Studio open at this point, you're going to need to close it because the environment variables are read in when the program starts, okay? So if Visual Studio was running, you now have to close it, and then you're going to reopen it later when we go to edit our project, okay? So make sure that that was closed right now at this step. So this step will not work if the environment variable has spaces in it, yay Windows. So it says if you're on a lab machine, this step will not work. We're not going to be using the lab machines for this course because we're all remote, so ignore that. If you have Visual Studio open, you need to restart it now. Okay, so we've said all that. Step 5, the next step, download and extract the assignment zip file from the link that was sent to you via email. So I've sent out a request on Discord for people to tell me if they got the email. If you're registered in the course, you should have gotten your email with your personalized download link for the assignment, okay? So once you have that, let's go over here now. I'm going to minimize this. We no longer need that folder. And I'm going to take this over here, and we'll go back here. So these are my files for 4300. I'm going to extract this to this folder. So now I have my assignment extracted to this folder. Okay, so navigate to the Visual Studio folder inside that folder. All right, let's go to Visual Studio. And now we see here we have a solution file, a VCX proj file, a filters file, and a users file. So Visual Studio uses things called solutions. So the solution can contain multiple projects. For this course, this is an older version of my instructions. I apologize. I didn't rename this. So this Sfml game.solution, this is now A1 Tron.solution. So I've renamed those so that name is a little bit different. So if you don't see Sfml game, that's because they've just been renamed to another solution. So this solution file, double click it. So let's see what happens. I haven't tested this yet. Okie doke. It opened. Looks like we're good to go. Now this is running in a virtual machine, so this is going to be taking a little bit longer than it normally would on my main machine. All right, so let's move this over to the side so I can continue. If you shouldn't see any warnings pop up. If you do, click OK, and let's hope that things work. So now you will need to tell Windows where to find the Sfml DLL files by adding them to your path environment variable. So in Windows, DLL files are called dynamically linked libraries. So these are libraries, okay? If you have any updates for Visual Studio, you might want to install those. That's the notification that I just got. And these dynamically linked libraries are needed in order for your library to run properly, okay? So for example, Sfml came with a bunch of these DLLs so that you don't have to recompile all of Sfml, okay? So what you're going to need to do is you're going to need to tell your machine where those DLLs are so that when you go to actually run your program with Sfml, it will know where those DLLs are, okay? So yeah, I know Windows is annoying, but we'll only need to do this once for the first assignment. Okay, so again, we're going to go back to our environment variables. So let's open this up. Then we are going to go into environment variables, and then we're going to go to our path variable. So click on the path variable and click edit. Okay, that's what I'm going to do. Next, it says type one of the following. Okay, so you can either type percentage sfml underscore dir percentage underscore or slash bin. So what this means is it says read in the environment variable called sfml dir, and then it's the folder called bin inside that folder. Okay, so if you look over here, I have that done already. So sfml dir slash bin. And if we go back to the sfml folder, inside the sfml dir slash bin, you see this is where all those DLLs are. So what adding them to the path does in Windows is that if your program needs any of those DLLs, now Windows knows the directory to look for those DLLs. Okay. Similarly, if you want to, but I don't recommend, you could hard code the path like whatever slash bin in your environment variables, but I don't recommend doing that. Just use the variable that we created before. Okay. So now we're going to click OK. We'll click OK, and now that should be done. All right. You may need to restart Visual Studio after this step if it says DLL not found. Okie doke. Next step says in Visual Studio, switch from debug to release mode. Okay, so debug, we're going to switch from debug to release mode. Debug versus release. The debug mode enables a whole bunch of debugging symbols and lets us step through the program. We're not debugging right now. We want to build the release mode, which is the fastest version of the code. And if at some point during the term you're working on one of the assignments and your code seems to be running unreasonably slow, it's probably because you have debug mode turned on right here. So please make sure that you have release mode turned on. All right, so click release mode, and then I said click the Sfml game project. That is actually the A1 Tron project, and then click build. So now we're going to click build, and we're going to see what happens. So down here we get our output. This window will probably be a bit bigger for you. All right, so it says 1 succeeded, 0 failed, 0 up to date. What this means is that the project that we tried to build one project that was A1 underscore Tron. One of those projects succeeded, so the project succeeded, none of them failed, and 0 were up to date. So if I right click and I click build again, then it just says 0 succeeded, 0 failed, 1 up to date. So what that means is, since the last time we tried to build this project, none of the source code has changed. So Visual Studio is really smart about this. It looks through your source code, and it only recompiles what needs to have been recompiled, which is what has changed since the last version of your program was built, okay? So if it says 0 succeeded, that doesn't necessarily mean things failed, because if it was still up to date, then, you know, that's fine. Okay, so if everything was successful, no error should pop up. To compile and run in one click, instead of right-clicking and producing the exe and then running the exe, you can just click Local Windows Debugger up at the top. So this button is how you're going to run your stuff most of the time. And when you click this button, what happens is it's going to compile your default project. So by default, there's only one project here, so it's going to compile that, and then it's going to run it. So let's click that, and it should say everything's up to date, and then it's going to run our assignment. And here we go, we are running Tron. Okay, so that's Tron. It's got some randomized AI people in it. This is the Sfml window that's showing up. We've got a little bit of a grid with some AI that's going on here, and I'll explain what all of this is once we get into the assignment. But that's basically it. Okay, that's the setup for this assignment, and will also be, once you've done that, it doesn't take very long. How long, what are we in, 20 minutes now? And I've been going very slowly. That's how long it takes to set up, and it will be the same for all future assignments. So for all future assignments, we can just download the zip file, double-click the solution file, and click compile, and everything should run for us. Alrighty, so if you're on Mac, if you're on Linux, you just follow those text instructions. It's actually much simpler, and you should have no problem doing that. So a couple of common errors that people run into. If it says that Sfml, so down here in the output, if there's an error, it's probably going to be that it says sfml/graphics.hpp not found. If you get that error, it's probably because you didn't do step 4 properly, where you tell it where the Sfml directory is. So it may be that you didn't restart Visual Studio, or maybe you typed in the folder wrong, or maybe the folder has some spaces in the names. If it says DLL not found, then you didn't do step 9 correctly. So again, maybe you had an error somewhere in your typing, or you didn't restart Visual Studio. And finally, if it says, this used to be an old error, you won't find this. It has to do with Windows SDKs. But if you are, like, for some reason using Visual Studio 2017 or something, here's how you can fix that error. But you shouldn't get that error anymore. Okay, so let me very quickly, for Linux, all you have to do is sudo apt-get installed build essential and lib sfml dev. Okay, so build essential, that'll install the GNU C++ compiler. G++ will install that. Build essential installs all the C++ libraries you need, and sfml dev installs all that you need. And then inside the project folder that you've extracted, you can either copy and paste this single command that will compile all of your stuff, or you can run the make file that I've included with the zip file. So you just type make, and then that'll compile it for you, okay? And the Mac instructions, all you have to do is brew install sfml and then start the Linux instructions, starting with assignment with step 1. Now, for Linux and Mac, you can use absolutely any program that you want to edit the source code, okay? I'm not suggesting any IDE. So for example, I know that what's the thing that Mac people like to use? I think in the Mac instructions here, it tells you to use some IDE that's really popular for Mac. You don't necessarily need to use that. What you can do is just edit in Notepad if you want to, and then go over and type make, and it'll compile your program. Okay, so that's the setup for the assignment. It should be really no problem for you at this point in your CS career. Okay, so that's all set up and done. That was my kind of blank virtual machine here that I had running. So I'm going to leave the virtual machine now. Xcode, yes, thank you, someone in the chat. So if you want to use Xcode, you can, but I cannot help you with the setup of Xcode. Just letting you know, because I don't have a Mac. All right. So let's go over to the actual project here now, and we will start editing some code. Okay, so where am I going? All right, here we go. So once you've extracted your assignment zip file, you're going to be left with these files here in this directory. Okay, so you're going to see a readme.txt, you're going to see a marks.txt, you're going to see a makefile, and 3 directories. So over here in the bin directory, that's where your compiled executable is going to go. It's where the font is and where the config file is. I'll talk about that a little bit later. The source directory is where all the source code files are. So all the headers and all the CPP files are in the source directory. And the Visual Studio directory is going to contain those 4 files that came with the assignment. And you're also going to see some temporary directories here. This is where Visual Studio puts its like the equivalent of the object files. So you see here .obj, that's like the intermediary combined object files that, that Visual Studio uses. And also a .vs folder, which contains a whole bunch of random crap related to debugging that you never have to worry about or open. All right, so let's first open the README file to see what this assignment is all about. Excuse me. So we're just going to read through this, see if we can find any typos, because this text file explains exactly what you have to do for each of the assignments. So, COMP4303, assignment 1. For this assignment, you will submit one file, source/tronai.cpp, as you should only be modifying this file for the assignment. If you submit any additional files, this will result in a loss of marks. Please do not submit a zip file containing this file, just the file itself. So this is a computer science program. I know that I seem to be being overly pedantic, but that is who we are. We are computers, right? We are code writers, and we have this like marking process that's pretty streamlined, but it's only streamlined if people follow the submission instructions. So I've set it up, I believe, on D2L, so you are only allowed to submit a single CPP file for this, so it shouldn't be too much of an issue. But just make sure that you're only submitting that single file. You must include the following in info at a comment at the top of the file. So all students in the group, so if you're working by yourself, just you. If you're working with a partner, then you and your partner. And if you are working with a partner, only one of you submits the assignment, okay? Not both. So all of the students' full names, CS usernames, and student numbers. And if you didn't get something to work, just include a little comment there saying what you tried, because we can give partial marks if you actually tried it and it didn't end up working. Okie doke. So here's the project specification for this assignment. In this assignment, you will be writing an AI for the game of Tron. You only need to modify the Tron AI student get action function within source/tronai.cpp. All right, well, let's see what the hell Tron is before we go any further. If you're not familiar with the game of Tron, what it is played on a grid. Okay, let me see if I can make this a bit bigger. There we go. All right, so Tron is played on a grid. And on this grid, we've got these light cycles, okay? So Tron, the movie, was a movie, science fiction movie back in the 80s or something. And essentially, you're riding around on this light cycle. And as you're moving, you're leaving a trail behind you, okay? So that trail, if any other player crashes into that trail or crashes into the sides of the playing field here, then that player dies, essentially. So if you see, all of these players here are, now the green one is a little bit more intelligent than the others because the others are sort of random. But what you see is this guy is just driving around and trying to fill up as much of the area as possible because filling up the area means that you're living as long as possible, okay? So over here on the right-hand side, you see each of those players and the players' names. So you see here group name 4. Well, group name, that is going to be where you're editing your code, okay? So by default, the AI that controls that Tron is just saying go up as far as I can. And you can see that going up is not a very good strategy when you start really close to the top, right? So group name, all it does here, the number represents how many cells that it was able to fill out, right? So group name 4 means that it survived for 4 cycles, okay? So each iteration, essentially, you're choosing a direction to move into. Your cycle goes into that cell, and then we resolve any collisions and see who died, okay? Random here literally just picks a random direction to go into, and that survived for 13 cycles. Random safe is another algorithm that I'll show all the code for these algorithms. I've included them as sort of examples for you. Random safe survived for 67 cycles, and go straight, that's this green one, survived for 386 cycles. So if I run your code and your player gets the highest number, then you win, okay? So what you're doing for this assignment is you are writing an AI for Tron, right? So you have access to this game state with all of the numbers, where like you can access all the occupied cells and see where the player's current position is, where they've already been, and so you can try and avoid obstacles and all that sort of thing. And we're going to run a tournament in the class between all the submissions, okay? So you're going to write an AI, and one of the lectures in this course is me just taking all the projects and running a big tournament for all the people in the class. And I think it'll be really fun, and we'll, have some sort of prize or something like that for the winner of the competition. All right. So that's what Tron is. Now let's see how you're actually going to be implementing that. So let me just go through the code. So when you open up Visual Studio, you're going to be presented with this sort of blank screen, right? So over here in the Solution Explorer, your Solution Explorer may be over on the right-hand side or the left-hand side, but it's the same thing. So we're going to click this little arrow just to open up the Tron AI project. Now, I realize that my font is a little bit small here. I apologize for that. I forgot the setting that opens this up. But here are all those source files that are in that project. So if you single click on something, it sort of opens it up temporarily. If you double click on something, it opens it up as a tab, right? So now I've got main and Tron AI open up here. Okay, so I want to show you how this program works and explain to you the interaction between the AI system and the Sfml user interface. And then we'll go into the rest of the assignment. So every C++ program has a main function. And what this main function does here, I'll make this bigger for sure, is it's very simple. It sets up a Tron GUI object, and it passes in a configuration file. And then it just says, hey, Tron GUI, run. Okay, so I've set up this so that it's very object-oriented in this class. So we set up a Tron GUI object, and we tell the Tron GUI to just run for however long it needs to run. But let's have a look at this config file first, okay? So if we go back into the directory that our file was extracted to, or sorry, our assignment was extracted to, and we open up config.txt, here's what we see. So in the config.txt, we see, okay, first is the size of the Tron arena, okay? So this is the X size of the arena, this is the Y size of the arena. So if I run the assignment again, it should be 64 cells wide by 36 cells high, okay? That's what that is. And then if I go back into config, I'm going to have some players here. So I say player student, player random safe, player go straight. And over here, essentially, this means this player is going to be controlled by the AI called student. It is going to start at X location 3, Y location 3. And in the assignment here, oh, sorry, Tron is still on the screen. My apologies. Okay, so player student, the next two variables are going to be the starting location of where that player starts on the screen. Okay, so here it says 3, 3, meaning 3 in the X location and 3 in the X direction, 3 in the Y direction. And then the next 3 are going to be the color of the player on the screen. Okay, so this is RGB, so red, green, blue, 255 red means 0, 0, green, and blue means that this player is red. So if I go back to the Tron screen, then we can see here that group name, which is actually the, what you're going to change your thing. So this is player student. It is red, and it starts 3 in the X direction. And in Sfml, we count Y going from top to bottom. So 0, 1, 2, 3 in the Y direction. Similarly, if we want to see, okay, what's random safe doing? Well, random safe looks like it's over here somewhere. So random safe starts at 60 in the X direction and 3 in the Y direction. And it is RGB 00255. So the B is the only thing with a value, so it's blue. Okay, so that's what the config file does, and that's why we include it. So we can include any number of players in a Tron game. And if I say, for example, changed student to be 3030 here, and I run it again, then the student will start like way down here at 3030. All right. So that's what that config file does. So let's change this back. Perfect. So that's the main file. It just sets up this object. It passes in to the constructor a config file, and it's going to read that. So now let's go into the Tron GUI class and see what's going on there. Okay, so in C++, if we want to see sort of the overall view of what a class does, we're going to look at the header file. Okay, it's going to tell us all the class variables that it has. It's going to show us all the functions that it has, etc. So here's the Tron GUI class, and these are all the private functions and the private variables. So it's going to contain some private variables. What are those variables? Well, we have a path. That's the path to the config file. It's going to contain a Tron Battle. So the Tron Battle object is actually going to contain all of the light cycles. It's going to contain the map. It's going to contain where people are, the decisions that they've made. So that battle thing, that controls all the actual logic of the Tron Battle itself, all the physics, all the collisions, stuff like that. We're going to get into that one, but the Tron GUI is essentially responsible for user input and drawing the Tron Battle, okay? This SF render window, that's the window, the window object that all the things get drawn to. The font is the font that is used to draw to the screen. The text, that's the text we want to draw to the screen. I've got a little clock here in case I needed to time anything. The grid size is the size of the grid cells in the window, so you can change this and it will change the size of the grid cells. It won't affect the Tron Battle, it'll just sort of resize bigger or smaller. And then we have a Boolean here, whether or not the game is currently running. That's about it. And then we have some helper functions down here, like setting the map, doing the user input, drawing lines, etc., etc. And the only public-facing functions for this class are the Tron GUI constructor itself and the run function. So if I go over to the code now to see what's actually happening, so here's what happens when you construct this Tron GUI. It passes in the path to the config file, it sets the config file path, then it sets the map, and so calling the setMap function essentially just sets up the Tron Battle object, okay? So the Tron Battle object, like I said, it contains all of the logic for the Tron Battle. Then it calls init, and init initializes all of the graphical elements for the user interface. So it does things like it creates the window with the battle width and the battle height size times the grid size. It sets a frame limit of 60 frames per second. It loads the font, it sets the text, all that kind of thing. So that's what init does. And then all it has is this main loop. So in the run function, it just says, while the program is still running, do a turn of the Tron Battle. So one turn is one movement. Then handle the user input. So we can click some keys in the user interface to do some things, and then render the scene. Okay? So if I look here, we've got a line drawing function. That's not super interesting. Here's the user input function. So the user input is basically just going to do two things. It says if we tried to close the window, so this event.type equals SF event closed, that's what happens when I click the X. So all that does is it says, whenever I try and close the program, set running to false so that the program doesn't infinitely loop and do nothing, okay? Then I have one other type of event here. This is the key pressed event. And so the key pressed event essentially just says, if I press escape, quit the program. If I press R, restart the map. Okay, so if I'm running my Tron program and I want to do some testing here, I can just hit R to restart the map whenever I want, and it'll like reset the randomness and all that kind of thing. Okay, sorry, it does not reset the randomness, it just resets the map. Okay. Then after user input, there's just some helper functions, and then comes the Sfml rendering of the actual scene itself. And now you don't necessarily need to know how this works, but I'll just explain it anyway because Sfml is super easy. So the first thing you do when you render the scene is you clear the background, so it draws a completely black screen. Then I set up the grid size, so I just set up this temporary variable g, and I set up a rectangle shape that is of size grid size by grid size. So if grid size is 16, essentially what I have here is I want to be able to draw all of these little rectangles that represent the players in the screen. So I set up a rectangle shape, and that rectangle shape is just going to have the same size of 16 by 16 pixels. Then I'm going to loop over every tile in the grid, and I'm going to draw the proper color for that tile. So for X and Y, I'm looping over the battle width and the battle height. That's the number of cells in the battle. Then blank tiles are -1. So I haven't explained this yet, but essentially every tile in the grid is going to be given an integer value that's unique to each player. Okay, so for example, there's player 0, player 1, player 2, player 3, but blank tiles have no player on them. So I've just said that -1 means there's no player on it. So I'm going to call battle.getTile, and battle.getTile will give me the integer value of the player that's on that tile. So the map is just a 2D array of integers, essentially. So this value is going to be what I work with to set the color. And then what I do is inside the battle, I can get all of the cycles. So the cycles, we're going to go into that in a second. The cycles contain the color that they should be drawn on the screen. So I just said for each cell, if there's no player on that cell, well, the background is black anyway, so I don't need to draw anything. But if there is a player on that cell, look up the player's color, set the rectangle color to that player, then set the position of the rectangle to the proper place in the grid, and then draw the rectangle. Okay, and that's it. That is the only thing that the GUI does, is look up those color values and draw the rectangles. Then the other thing that it does is it draws the lines to the screen. So, for example, if I comment out these lines of code where it doesn't draw the lines anymore, what we're going to see is that grid structure is no longer there. Okay, so that grid is no longer there, but I think the grid is a little bit helpful, so we'll keep those lines being drawn. And then it just goes through each player, it gets the score, and it draws the name and the score over on the right-hand side of the screen. Okay, and then window.display does the buffer swapping and actually draws everything to the screen. So that's what the UI does. It's very, very simple. And in Sfml, you can see this is pretty much the minimum amount of lines of code in any programming language that you could use to draw this user interface, right? So I'm drawing rectangles very, very cleanly and quickly. I'm drawing text very quickly. So anyone who tells you that things are necessarily harder to do in C++ is not using modern C++ and modern libraries. Okay, the next thing we'll do is we'll look at the Tron Battle class. So that was the user interface. Now we're looking at the Tron Battle class. So before the Tron Battle class, I have a little object here called direction. So a struct in C++, if you see a struct, it's essentially just a class. So in C++, a struct is a class where by default, all member variables are public. Okay, so if I want to create a quick little class here with just like an X and a Y called a direction, then I can just say struct direction, and that's got an X and a Y in it. So I'm going to use that direction later on in the code. Okay, so Tron Battle. that is my main class that's going to store all of the data related to the level and related to the player's cycles. Okay. So here we can see that I have a width and a height for the battlefield. I've got a vector of vectors of ints. So essentially in C++, if you want to have a 2D array, well, the easiest way to do it is with the vector class. So a vector of vectors is essentially a 2D array. All right. And I call that level because the level is just a 2D grid of integers. Perfect. Next, I have a vector of Tron Ai objects. And in order to accomplish inheritance, well, how am I going to explain this? So please watch the intro to C++ videos. So Tron Ai over here is a base class, and all the different AIs are going to be derived classes of that base class, right? So over here in Tron Battle, I want to have a single container that contains all the AIs. So I have to have a vector of the base classes. So in order to have a vector of base classes in C++, you have to have a vector of pointers to the base classes. So that's why this is. So we're using shared pointers. We're never using any raw pointers in this class because we're doing sort of modern C++. So we have a vector of shared pointers to Tron AIs, and that's the AIs that are going to control the players. Okay. Then we also have a vector of Tron cycle objects, and the Tron cycle object is going to contain all of the data about each of the players where they currently are, and that is the cycles object. Then the last thing I have in here is a vector of the legal directions. So the legal directions are simply up, down, left, and right, and up, down, left, and right are these direction structs that I had before. Okay, so up is going to be 0 in the x direction, -1 in the y direction, because y is negative going upwards. Down is 0 in the x direction and 1 in the y direction, so down is positive in the y direction. Left is negative in the x direction, and right is positive in the x direction. So I've just given you here, for your own benefit, a vector of the legal directions that you can move in. So basically what's happening is you're writing a function where, given this is your current Tron cycle and this is the current level, what direction do you want to go in? And every turn of the game, you're going to be returning an index into this vector. Okay? So if you return a 1 in your AI, that means down. Because this is the 0 index, this is the 1 index. So you're going to be returning the index into this. All right. Before I go too much more into the Tron Battle, I want to go into the Tron cycle class, because you need to know what the cycle is in order to understand what the Tron Battle is. So here is the Tron cycle, and the Tron cycle is going to have a number of variables. So the Tron cycle is going to have an integer ID. So each cycle has a unique ID. So I'll be player 0, you be player 1, this other AI is player 2, player 3, and that's so we can distinguish players from each other, right? And also, whenever you move on the map, you're essentially leaving a trail of your ID in that 2D array of integers. Then it's going to have, oh, by the way, my naming scheme for C++, I have an M in front of private member variables. So if you ever see M underscore, that means that is a private member variable. So M for member, and then is the name of the variable. That's just a naming scheme that I really like and just understand what that means. So M underscore ID, wherever you see that in the code, you know that that's a private member variable. All right. Next, we have the X and Y location. That is the current X and Y location of this Tron cycle on the map. Okay? So if it's currently at 2, 6, then it will be 2 and 6. Next is the mdir variable. That was the previous direction that you chose. Okay? So I'm storing that for you because sometimes you may want to know what was the last place I was. right? Or yeah, I guess that's correct grammar. So what direction did I take on the last move? So for example, if I want to keep going straight, I need to know where I came from, right? In order to go the opposite way. So this direction will say, that stores where you came from, what direction you chose on the previous turn. The color is your color. The score is how many tiles you're currently occupying. And alive means whether or not your Tron cycle is currently alive. So if you have collided with a wall or another cycle, then alive is going to be set to false. And then because those are all private variables, I have a number of helper functions to get at that data. Okay, so that's pretty simple. And a constructor taking in the ID, the starting X and Y, and the starting color of that Tron cycle. So that's all a Tron cycle is it stores the current location, the previous direction, and an integer ID and the color and stuff like that. Okay. And so a vector of Tron cycle objects is inside the Tron Battle class. Okie dokie. Now that we know what a Tron cycle is, we're going to look at the Tron Ai class. Okay, so the Tron Ai class is a base class. By default, it has only one member variable called name, and that's default. And then it's going to have a constructor. It's going to have a function which allows us to get that name. And then it has a virtual get action function. So a virtual function in C++ just means that if you implement a derived class of this class, then you're going to call the derived class's version of this class. Okay? So for example, if I have Tron Ai student, which inherits from Tron Ai, then whenever I call a base class pointer's get action function, it's actually going to call my derived class's get action function. So that's what virtual here means. It's a virtual lookup table. I'm not going to get into all those details. You don't need to know that for this course. The get action function is going to take in a battle. So this is a const reference to a battle, meaning that you can't change the state of the battle, right? So if I pass you in a battle, you're not allowed to just put your light cycle wherever you want. So the battle is const, meaning that you cannot change it. And your cycle is also const, meaning that you can't randomly teleport yourself to a safe place on the map. And then here in the base class of Tron Ai, you see that this virtual function equals 0. What does that mean? Well, in C++, that's your way of declaring this as an abstract class. So you cannot instantiate the base class of Tron Ai because this function does not have an implementation. We've basically said that this function is null, so we can't actually instantiate a Tron Ai class. So that's sort of our way of making this kind of like a Java interface or an abstract class, okay? Then, each one of our derived classes is going to implement those things as well, right? So all of these things look exactly the same, but the code is going to be different. Now, typically when you write C++, you're going to have each of these classes in its own header file, its own CPP file, but I didn't want there to be too many files in this assignment. So all the header files here are in one tronai.h header file, and all the code for all of these is inside the tronai.cpp file. Okay, so your job in this assignment is basically just implementing these two functions. So inside tronai.cpp, you are going to be writing tronai_student. All right. So what I want you to do is you're going to replace group name here with your group name. So for example, if I was working with John Smith, then I will type Churchill Smith as my group name here. That's all you have to do inside here. So you have to change the name. And any other things which you want to do in the constructor, you can do here, but it's possible that that's literally the only change that you make to that function. Okay. The majority of the work, probably 99% of it for this assignment, is going to be in the get action function. So the get action function takes in a Tron Battle, and it takes in a cycle, and it returns a direction. So just keep in mind that whatever you return here, that is the index into this Tron Battle legal directions array. Okay, so over here, the default student, which is now Churchill Smith, is always returning 0 for its action. So if we look over in Tron Battle.h, action 0 is move up, right? And you saw before that player just moves up and dies instantaneously. So let's say I want to move right. Well, right is in the last index, so that would be index 3. So if I change this to be 3, now that player, whenever it runs, is going to be moving to the right all the time. So that red player, instead of moving up, did a little bit better because it moved to the right. Okay? So that's what that does. And all of your smartness is going to go in here, just above that return statement. But I still haven't shown you sort of how to do that sort of thing. So I have written for you, as you see here, there's Tron student, that's what you do. I've written a Tron Ai Random, a Tron Ai Random safe, whatever that means, we'll figure it out, and a Tron Ai go straight. So we're going to look over those as samples for how you actually access the data in the cycle and how you access the data in the battle and how you're going to produce your move. All right, so let's come down here. This is the Tron Ai. This is the code for the base class. You don't need to touch any of that. In fact, anything under here you can look at, but you don't need to touch it. Okay, actually, in fact, don't touch it because you shouldn't modify the existing players, but you can look at them for inspiration. Okay, so Tron Ai Random. Let's see what this does. Well, first it sets its name to random so that when it's drawn to the screen, it draws random. Oh, and let me test this real quick. When I change the name up there in the code, so it draws Churchill Smith over here, right? So that's how your name is drawn to the screen. So Tron Ai Random, here is the get action function for Tron Ai Random. It's pretty simple. So again, you're given this battle object that contains the map data, and you're given the cycle, and the cycle is what is the cycle that you're currently making the decision for, right? So if the cycle here is like the yellow cycle, then that is, you are making the decision for the yellow cycle. If it's the red one, then you should be making the decision for the red cycle, etc. So I have some helper functions in here for you, and maybe what I want to do is get the legal actions for a cycle. Okay, so you can move up, down, left, or right, but inside the battle class, I have a function called get legal actions. So let me see what that function does. So we're going to go over into get legal actions to see what this does. So get legal actions for a cycle, it's going to create a vector of which is initially blank called legal actions. Then it's going to iterate through all of the actions, and it's going to figure out which of them are legal, right? And we'll see what legality means by inspecting the code here. So I say for size t is essentially just an unsigned integer for those who are unfamiliar with it. So for action equals 0, action less than get num actions. So the number of actions is equal to the size of that legal actions array. So that's 4. Action plus plus. So I have a isLegal action function, which takes in a cycle and an action. And again, remember, actions are the integer index into that random array, into the movements array. If it's a legal action, push back, which means add it to the end of the legal actions array, and then return the legal actions. Okay, so now we have to inspect what a legal action is. So here's the isLegal action function. It takes in a cycle, so we're going to be querying whether or not this action index is legal for this particular cycle. So what we're going to do is we're going to look up the direction. So this is the old direction, and if we look up in our directions, the cycle's direction. So this is a little bit confusing, but let me explain. If we want to know what direction our cycle took on the previous turn, then that's cycle.dir. Okay? So cycle.dir was the previous direction. So that's why I call it old direction. And remember, that's the index into this actual directions array. So this action, that's the index. Now we want to get the actual XY values of that action. So I have to call directions with that index. Okay? And then that direction, I'm saying a const direction older equals directions and then this. Now I want to look up the X and Y direction values, like the direction values of the action that I'm trying to determine whether or not it's legal. So that is the new dir. And basically, I'm just saying that it's not a legal action if it goes backwards into itself. Okay? So let's see what that actually means. So let me open up, I probably blinded you with that here. So let's go 1,000. What is going on here? Okay, 1,000 by 1,000. Oh, that's percentage, sorry. So here we are going to have our grid. I'm not going to draw it perfectly. I apologize. Okay, so let's say that my cycle is red and I'm currently at this location. If I have chosen to move right, okay, then on the next turn, I will be at this location. If I choose to move right again, on the next turn, I'll be at this location. So, what are the legal actions that I can take from any given location? Well, I'm basically saying that any action, so here, I want to change my color, moving up is legal, moving right is legal, moving down is legal, but moving back onto yourself is not legal. Okay? Now, it doesn't really matter. Maybe I shouldn't have had this legal action thing. It's just there for you as like sample code of how to access data. But essentially, if you choose to move in the opposite direction of your last direction, then you're moving back into yourself, which will always kill you no matter what, right? So, for example, maybe up here is the yellow player. Maybe over here is the green player. Those are still legal actions, right? You can still move there, but you might crash, right? So you're going to have to check if you're going to crash, and we'll get into that in a second. But essentially, you're only choosing from 3 different actions at any given time, right? And that isLegalAction function is going to give you the indices of those 3 legal actions. So again, if you are right here in this red spot, moving back into yourself, the opposite direction that you just came is not legal. So if we look at that in the code, it just basically says, don't move back into yourself. Okay? All right. Now, if I go into Tron AI, so the random Tron AI is going to say, get me those legal actions, then I'm going to choose a random index from those legal actions, right? So here, those legal actions may be something like 0, 2, 3, right? So what I'm going to do is say, give me a random number modulo the legal action size, and that's going to give me essentially a random index into this vector. And so the random action is going to be rand mod legal action size. That's going to take out one of those random things from this legal actions array. Then I'm going to take out, well, that's actually the index. So I look up inside legal actions the random action. Okay? Now I could have shortened this a little bit. I could have said the following. I could have just said return legal actions and then this. That would have been a little bit shorter, but I wanted to spell it out for you a little bit more so you can see how to get like a random action and then test something with it. So that's literally just that's the random AI. It's so simple. You get the legal actions, you choose a random index from this array, and you select the index that you randomly chose. That's all. Okay, but as you can see here, this didn't do anything with the battle. right? I'm just choosing a random action. I don't care if it's safe or not. So that's a bad AI, and that's why it usually dies so quickly. Because I'm just saying, go somewhere up, down, left, and right, and you can see random here usually runs into itself or the side of the wall pretty quickly, right? So don't be random, is what we're saying. Okay, next is the random safe. And what random safe is going to do is it's going to choose a random action that will not immediately kill me. Okay, so let's go back over here to this. So I'm currently right here as the player. So I can't go back into myself. So that's not a safe action because it's not legal. Let's say that the green player is up here, right? So what the random safe player is going to do is it's going to build an array of the safe places that I could go. So it's going to look up and it's going to say, that's not a safe place, so I can't go there. It's going to look right and it's going to say, this is a safe place, I could go there. It's going to look down and it's going to say, oh, that's a safe place, I could go there. So it's going to choose randomly between going right and going down. So that's the random safe player. It's just a little bit smarter than random and is why it usually beats the random player. So let's see now how we would implement this inside our assignment. Okie doke. So I'm going to build an array of the safe actions, okay? The safe actions essentially are the ones which immediately won't kill me. They might kill me 2 turns from now, but at least they won't kill me on the next turn. Now I'm going to look through each legal action. So up here, what I did before, when I iterated through things, I used an integer index for loop, right? So for index 0 to whatever, look at that index. But here I'm using a range-based for loop. Okay, so C++ has modern range-based for loops. And I'm just saying for every action in the legal actions of that cycle, and call that variable action. So for all the legal actions, and remember, legal actions are the ones that don't go back into myself, I'm going to check where I land if I take that action, and then I'm going to ask the battle if it's safe. So here's what's going to happen. Let's say this is the current situation, right? So this action is not legal, so we're not going to check that one. So what we're going to do is we're going to look through all of the actions. And the actions array, if we saw before, is going to be, well, we're going to look through the legal actions. So let's just say that we happen to iterate through that up, right, then down. Okay, it might not be that way in the actual array, but we're going to go up, right, and down. So first, it's going to look up, and I want to have, let's say this one is not safe. Okay, so up is going to be, the action up is going to be 0 in the x direction and -1 in the y direction. So this place here, this is going to have an x and a y, right? This is my current position x and my current position y. And so the new place that I'm going, this new x is going to be equal to x plus the x value of the action, right, which is 0. And the new y is going to be equal to the y that I was -1, because this is the, or plus -1, which is the y value of the action. So that is this location. Then what I want to do is I want to ask the battle, hey, what's currently at that location? So that's what we're going to do. So over here, I'm going to get the direction of the current action. So the way that I take this action, which is an index, and I'm going to get the direction, which is the x and y movement of that index, is to say battle.getDirection of that action, right? And that gives me this x and y. So now I'm going to do the calculation of my new x location and my new y location. So the new x location is the cycle's current x location plus the x value of the direction, right? So it's my current x location plus the x value of the direction. Similarly for the y. Now what I want to do is I want to query the battle and say, hey, what's at that XY location? So I've included a function for you here, which is safe. So battle.isSafe will look up a location and tell you whether or not it's safe, which means there's no other cycle there at the current time. So let's go over to Tron Battle and look at the isSafe function and how that's implemented. Okay, so the isSafe function takes in an x and a y, and it's going to say, okay, first of all, is x greater than or equal to 0? Because that's the bounds check with the screen. So first of all, isSafe is going to say, it's only safe if it's not moving off the left side of the screen, if it's not moving past the top of the screen, past the bottom of the screen, or past the right of the screen. So those are the 4 checks. And then it also has to check whether or not the value of the grid is currently blank, which would be equal to a -1. So it says, if x is greater than or equal to 0, and x is less than or equal to level.size, and y is greater than or equal to 0, and y is less than level x.size, meaning the height, and the level's value at xy is equal to -1. Okay? So if the level's value is -1, it's safe. So if all of those things are true, then it's safe. So back over here in our example, that would return true. So it would be safe up here, it would be safe right here, but it would not be safe right here. And the reason for that was because this one is currently occupied. All right. So back to the AI. So if the battle, if that location in the battle is safe, then I push that action, I add it to my vector of safe actions. Okay, so now I know all the safe actions. And so what I'm going to do is say, okay, well, first of all, if I didn't find any safe actions, then it doesn't really matter where I go, right? Because no safe actions would mean that like everything else here is occupied, so I'm guaranteed to die on the next turn. So if I have no safe actions, so if the safe actions vector size is 0, just return the previous direction. Or return literally any number, it doesn't matter. Otherwise, if we did find some safe actions, I'm going to generate a random number between 0 and the size of the safe actions array and return that thing. So it's essentially saying once you've calculated all the safe actions, then return a random one of those safe actions. That's what that does. Cool. And so what random safe does, if you can see, is it does a little bit better than random. It usually boxes itself in eventually, but you can see that because it's never intentionally turning in on itself or going off the screen, unless it's absolutely trapped, then it always does a bit better than the pure random function. Okay, so random safe here is this blue one up in the top right corner. So random safe, now we're getting a little better. But you can see that this go straight AI is doing way better than the others, right? So let's go see now what this go straight AI does. Okie doke. Well, it's actually pretty simple. So first, compute where the cycle will be if it continues going straight. So what does straight mean in this context? So straight essentially means that it's not changing direction, okay? So going straight means let's say I chose going right as my first action. Well, if I go straight isn't an up, down, left, or right, but straight means go in the same direction, right? Oops. So it's just going to keep going in the same direction. All right. So let's get the direction that I would be going in if I went in the same direction. So cycle.dir, that's the previous direction that I went, and I want to get the action, the direction related to that. So I say battle.getDirection, cycle.dir, that's D, and then I compute where I would be if I kept going in the same direction, right? So I'm just going to say my cycle.x plus the directions x and cycle.y plus the directions y. So nx, ny is where I would be if I kept going straight. Okay, so let's give an example here. Let's say that this is the current state of the game. So it says, where would I be if I kept going straight? Well, if I kept going straight, I would be right here. So what the AI is going to say is, if I keep going in that direction, if it's safe to keep going in that direction, keep going in that direction, right? So it's safe here. So what would happen on the next round is I would be right here. And then it's going to check again on that round. And it's going to say, is it safe to keep going in the same direction? This time it isn't. Okay. So what do we do? Well, here it says, if it's safe at that location, then keep going the same direction. So just return the previous direction that I chose if it's safe to keep going straight. Otherwise, we're going to have to compute which actions are safe and take a random one. So essentially, this AI keeps going in a straight line until it's about to hit something and then chooses a random safe direction to go if one exists, right? So here, what I could do is write all of that code to choose a random safe direction and then go in that direction, right? Because I wrote that code up here, right? Random safe. But I did write all of that code already, right? So instead of rewriting all of that code here, I can actually create a random safe AI and see what it would have done. See how that works? That's really cool. So I can build a bunch of AIs that do like really small, like clever but not complicated stuff, and then build another AI out of those AIs. So that's what I've done here. My go straight AI uses, if it's not safe, it uses the random safe AI. So that's pretty cool. So what I do is, if it's not safe to go straight, I want to go in a random safe direction. So I create a random safe AI, and then I call its getAction function on the battle and the cycle. And then you can see here now how that is working. So I want to really quickly, let's get an example here. Okay, so let's go back and let's analyze this get safe person. Actually, let's restart that. Okay, so here I am in a current state of the game. So get safe is pretty good, right? Get safe starts here, or starts down here, sorry. And it goes, let me get a decent color to do that. So it goes all the way up. Then it was about to hit something right here. It was about to hit this location. So it said, choose a random safe direction. Now, if you're actually creating an AI, like this is fine. It seems to work. It fills up a bunch of, the screen, but it's probably better to go to the right here than it is to go to the left, right? Because if we had gone left, we have far less space to work with. But we don't have any of that logic in. We're just keep that in mind for now. So then it starts to go to the right, and it goes all the way to the right until it was about to hit a blue, and then it chooses another random direction. Now, here is where it got lucky, right? If it had randomly chosen to go up, then look at this. It would be confined only to this area that it could no longer escape. But luckily, the random safe chose to go down where there's a bunch of free space. So when you write your AI for this class, if you're just doing random safe, then you have absolutely no chance of winning the competition or getting the full marks, okay? Because you have to have something in there that decides whether you want to go up here into this sort of small confined space or go down into the bigger space. So what is an algorithm? Now, most of you should have 3200, right? What's an algorithm that we learned that could tell me, okay, if I'm currently at that location and I want to know how much free space there is up here versus down here, what could I use? Someone in the chat tell me what algorithm will tell me sort of the size of the free space of that area. Now, this is the test to see if you really paid attention in the very beginning. Assignment 1 of 3200. Someone out there. All right, no one's answering. Someone said DFS. I would say BFS, okay? So let's say we're currently at this location and we want to know whether or not we should go up or go down. Well, something I could do would be the following. So let's choose a color that's not here yet. Let me choose purple. So up here, I'm going to do a BFS. Let's say, just for example, that red was like, red had occupied these locations. So I don't want to have to do a big, huge example, okay? So I'm going to do a BFS. So starting from here, I'm going to try up. Then I'm going to BFS out from there, then out from there, right? Then out from there. And eventually, what I'll do is I'll be essentially counting the number of free spaces in the best case scenario that I could go if I moved up. So what's that? Like 20-ish, right? So up there would have 20-ish possible locations versus down here we would have hundreds if we did the BFS, right? So something you could do is like take go straight, which is a decent algorithm. Maybe you don't want to go straight though. And down here is, if it's safe to keep going straight, go straight. But you could say something like, if BFS, right? If I have some BFS function, if BFS of going up is greater than BFS of going down, then return up, right? Now, of course, your code, this pseudocode, but choose all of the directions you could go in. Maybe try some breadth first search, something like that, or some other thing that evaluates essentially how long you're going to live in the worst case if you go there, okay? So you should do something clever like this. I want you, for this assignment, in order to get full marks, do something at least as clever as a breadth first search, okay? None of you will lose marks if you sort of go into this like really small area intentionally. You should not be going into those small areas. Okay, so that's the assignment. That's what you have to do, is you have to go up to this, go up to Tron AI student, replace this with your name, and then put your code for returning the action right here. That's all you have to do. Okay, but let's go to the marking scheme. Let's go back to the assignment file just to make sure that I'm telling you everything correctly. And I know this lecture went just a little bit long, but it's because we had to do the setup. Future lectures, like I'm really hand-holding you with the first assignment. The rest I won't be hand-holding you so much. So you have to implement Tron student get action function. You can create other functions if you want, but they all have to be in the tronai.cpp file, okay? So your function returns an unsigned integer corresponding to the index of the battle to be taken in the m directions vector defined in battle.h. So that just means you're returning 0 if you want to go up, 1 for down, 2 for left, 3 for right, etc. Directions are stored as a struct with x and y variable denoting the change in x and y change if that direction is chosen as the move. For example, moving right is a shift of 1 in the x direction and 0 in the y direction. So the resulting direction is 1, 0. In this assignment environment, y increases in the downward direction, so down will be 0, 1. Example usage of the direction can be seen in the example AIs in tronai.cpp. So R restarts the level, escape closes the game. Then down here, I have included the specification of the configuration file, because when we run the tournament, we'll be doing some four-person free-for-alls, maybe some 8-person games, maybe 1 versus 1, all that sort of thing. So you can edit the config file to test all of those things. Marking will be pretty lenient. However, you must do something significantly different from the examples. So the marking for this assignment is going to be a little bit subjective, okay? But I want you to do something that's at least as clever as just checking BFS, okay? Because that's what you're going to need in order to do well in the competition. You will get a max of 95% on this assignment unless you rank 8th place or higher in the in-class competition, okay? So what I'm doing here is you're going to be missing out on 5% of the mark unless you come in the top 8. So that's a little bit of motivation to get to do well in the class competition. And in order to get full marks, you must beat the sample AIs the vast majority of the time. So if you're losing to any of those built-in AIs that I gave you, you're not getting full marks on this assignment. It should do better than that. And that's it. I'm not telling you how to do it. This is completely open-ended. You are allowed to go online and look up Tron strategies, like Tron code, like all this kind of stuff. I don't mind. However, do not copy and paste solutions from online. You are allowed to use things as motivation. But if you do, you say, I used the following source as motivation for this method. And then you're going to say, you're going to give me the link to that source. Okay. So whenever you take someone else's code as motivation, or you read a strategy somewhere online, you have to cite that. Okay. I don't mind you doing it, but please cite it when you're submitting your assignment, and put that right here. Okay. The citing of that thing. And that's it. At some point, if I go back to this screen here, at some point in the future, we're going to have the tournament in class, and it's going to be when we kind of have a lull between two different assignments where we don't have a bunch of things going on. But I am going to run that Tron tournament at some point, probably between assignment 2 and assignment 3. All right, so that is it. I think I've covered everything that I wanted to cover. Yeah, that's it for this class. Thank you so much. I think you'll have a fun time with the assignment. And I wish you all the best in the class tournament. And I'll see you on Thursday for the next one. Thanks.